Okay, great. I think that we can start. So people continue joining us. Welcome, welcome. And once again, my name is Lana, and welcome to the Top Voices community webinars, community talks. Today we're talking about iOS development, and our speaker is Andrei Trifilov, iOS engineer at Bad Lab Technology. And Andrei will touch a very interesting and popular topic, which is connected to full screen video feeds that are quite popular now in startups and other apps. So this is quite a hot topic, and I hope this lecture will be super useful for you if you're planning to implement a full screen video feed in your app. So without further ado, let me pass the mic to the Andrei and start the lecture.
Yeah. Hello, everyone. Thank you, Lana. My name is Andrei Trifilov, and I am an iOS developer. And currently, I work as a senior developer at Bandlamp company. But before that, I worked at Yandex company, where I had experience with the video players. In my previous company, I worked in different departments, but all of them were related to video formats in various product scenarios. Since most of my experience is connected to video content, today's presentation will focus on this topic. I will explain why video players are used and show some examples of such applications. Then we will discuss the different categories of video content consumption in applications and take a closer look at one of them. After that, I will explain video formats, their differences, and how they are typically delivered to users. We will then move on a more theoretical section and examine the components that make up a video player on the iOS platform. Next, we will discuss what needs to be considered in the app's architecture to ensure smooth transitions between videos. Additionally, we will look at what analytics should be collected first to track video playback quality. And in the end of our session, we will have the opportunity to ask your questions and we will discuss it together. Okay, let's start. And nowadays, video formats is becoming increasingly common in mobile applications, even in those where it is a not car feature. In the past, integrating a video players required significant effort, so it was mainly implemented by services where video was the main product. However, today we have many tools that allow developers to integrate video players into mobile applications within minutes. This has made it easier to include video content and improve user engagement within apps. In some apps, video is central product providing incentive functionality, but in other, it's serves as an additional feature that improves social interactions within the product. But some applications just use the video content for small features like onboarding or maybe only for advertising. But all video consumption can be divided into several categories. The first categories, it is on-demand long videos. It is applications like YouTube, educational content, online cinemas. The next one, it is a short clips like a TikTok, Reels and Stories on Instagram. The next category, it is a live streaming. It is something like YouTube, Twitch, or maybe some sport broadcasts. And the last category is short inserts. It can be just only some advertising, or maybe you can use the video content for your onboarding in your application. Each of these video types has different consumption scenarios. For example, when watching a 4K movie, users are usually willing to wait a few seconds for buffering. However, if the same buffering happens with the short clips, it will create a poor user experience. Today, we will focus on integrating short video clips into an applications. But before, let's look how video works. On mobile devices, we can work with two main video formats. It is MP4 files or maybe HLS streaming. Additionally, we have one more format. It is a dash, but today we speak about Apple and iOS platform. And Apple doesn't support the dash format, and it is a reason why today we will touch only MP4 format and HLS. Let's start to discuss these formats. MP4 file format, it is a file which can be preloaded into the app during the build process or downloading from the remote storage. However, to start playing an MP4 video while it is downloading, the intro file must be downloaded first. This approach is not suitable for large files, such as, for example, 2-hour movie in 4K resolution, or, of course, it is not a good case for the live streams. And it is a reason why we can work with the HLS format, because HLS streams video in chunks rather than than as a single file. While some chunks are still downloading, the user can already start watching the video. And chunks, I mean the short segments of your video content. And if you need to switch between video quality, in case with the MP4 file, we must download a new file before changing the resolution. But in the HLS case, we can switch to chunks of different quality immediately. Also, HLS allows us to work with adaptive bitrate streaming algorithms, which automatically adjust the quality based on the network condition. And while HLS is a powerful format, it is also more expensive to support since it requires video transcoding. For short video feeds like TikTok style, each chunk typically lasts 3 or maybe 4 seconds or something around that, while the total video length can be much shorter. If your product deals with ultra short videos, maybe MP4 format it is a better choice for you, as it avoids the cost of transcoding. Additionally, video can be encrypted to protect content from piracy. And on iOS platform, for that, you can work with the FairPlay digital right management. It is a DRM, and DRM allows you to protect your video content. What does mobile app do with the video content? The first step, we have to download the video on our device. It can be MP4 file or maybe chunks from the HLS streaming. After that, we have to store this information in our memory in our device. And if encryption is used, it obtains the decrypt key and decrypts the video. And only after that, you can start your playback, render the video frames on the user screens, and you have to synchronize the audio track with your picture. Sounds complex, right? Fortunately, Apple provides built-in components that simplify these processes, and let's explore them core ones. iOS development working with the multimedia is primarily based on two key frameworks. It is AVKit and AV Foundation. These frameworks provide access to audio and video APIs on iOS. AVKit it is a high-level framework that simplifies video playback, and AV Foundation it is a lower-level framework that gives full control over media handling. And if you want to use these frameworks in your code, you can just import it in your file. The first important class in our video story, it is AV Player. This is a core class responsible for loading and playing video. It allows for essential playback controls such as a play, pause, seek, speed adjustment, and other features. If you want to work with AV Player, you can just create one exemplar of this player and use your URL with your MP4 file or HLS streams. The next class, it is the AV Player View Controller. This is a built-in view controller that simplifies video playback and includes default UI controls like play pause buttons, a seek bar, AirPlay support, and picture-in-picture feature. And if you use SwiftUI in your code, you can embed the video player using UI view controller representable class. The next guy is a AV player layer. If you need to render video on top of your custom UI elements without using AV player view controller, you can just use AV player layer, which is a CL layer subclass. You can see how you can just create some exemplar of this layer, insert your video player, and use it how regular CL layer in your code. The next important stuff, it is a audio session. When working with video, it's critical to properly configure the audio session to manage sounds playback. For example, stopping background music from other applications when you want to start video in your application. And for that, you can use the AV audio session instance. The next feature, what you can use, it is a picture-in-picture. And this feature allows users to minimize the video into a floating window while continuing to use other apps. AV Player View Controller supports this feature, if you remember that I mentioned it before. The next feature with the same situation, it is AirPlay. If your app requires streaming content to a large screen, you can enable AirPlay support in AV Player View Controller again, or maybe you can implement it manually. And if you use a SwiftUI, you can try to work with the AV Router Picker View for this feature. And the last one, it is AV Asset Download Task. This class allows you to download video without any playbacks on the screen. And this class will allow you to handle a background download process. Download process. And now let's look at simple implementation of a video feed in our mobile application. In my case, I use a SwiftUI code, and you can see how I use a UI view controller representable class. Here, I just create a AV player view controller, and I bind my AV player exemplar to this view. And this is a simple feed where I can use my video player view. You can see how here I use some items. It is an array with a URL with the content. The next, what I have, it is one exemplar of AV player. Also, I use a current video URL. It is something like my cursor, which allow me to control which video is focused for user. And for the scrolling feature, I use a scroll view with a lazy vstack components. And on unchanged method, you can see how I handle which video is on focus. And after that, I can just replace the current URL in my one video player. And after that, I can start to playback with this video player. And let's discuss the problems of this realization. In this implementation, the video only starts loading when the user scrolls to a video cell, causing buffering delays. And also, if you scroll back, you can see that you have to download your previous video again. To make the video feed smoother, we introduce a player pool, which preloads video before they're visible on screen. This way, when a user scrolls, the video are already buffered and ready to play. And this is my simple example of video player pool. But if you want, you can just improve this implementation. For example, if you want to control the size of your pool, you can just add some logic in this class and use it how you want. And now let's integrate this code in our feed. You can see how now I don't have and don't use any AV video player. Now I can use my video player pool. And on unchange method, I don't exchange one URL to the next new URL. And you can see how I just pause my previous player and start to play my next video player. And if I want, I can just preload my video where I want. For example, I can do it in on appear method. But remember that in this case, you have to think about the release players from the memory, because we want to save our memory and we don't have to collect a lot of players. And to ensure that users have a good video watching experience in your app, you need to track key metrics. These analytics help track engagement and identify potential playback. For example, you can use these key metrics to track. The first one, it is a start event when the video start playback. The next one, it is a pause and resume events when user just switch between pausing and resuming in the video. Seek event, it is case when the user skip forward or backward. Finish event when the video is fully watched. The next event is really important if the video content is main product in your application, because heartbeat event, it is a periodic checkpoints to track how far a user was watched your video content. And the last important stuff, it is stalled. It is a situation when your player can be cannot continue the video playback due to buffering, and also you can track the time users wait before playback resume. And to collect this data, we need to encapsulate the AV player logic inside a custom class. And basically, it is a good practice to wrap AV player inside the custom class that automatically logs event. And this approach allows you to control work with the AV player only in one place. And one more important thing to remember, the watch time, it is not a current playback position in your video player, because some user may seek forward without watching the skip portion. And so analytics should reflect actual engagement rather than just the final position. And in this example, you can use how user can start to watch your video from 0 position. Next, he watched to 5 position, and after that, he can seek the player position to 10 seconds, and after that, he just continue watch to 40 seconds. And in this situation, the current time is 40 seconds, but watch time of your content, it is 9 seconds. And let's summarize the key takeaways before you start developing a video-related feature in your apps. The first, define the purpose of video content in your app. Is it a core feature, or maybe just you want to use the video content like additional functionality? After that, think about choosing of your video format. You can use MP4 files for preloading, or maybe you have to use HLS streaming in your application. But if you want, you can try to use a hybrid approach in your application. The next one, consider the necessary functionality. Understanding which video components you need will help your plan development. And after that, you can implement a well-structured video player setup, managing playback, buffering, UI elements. And after that, you can think about optimization of your video feed. If your app has some scrolling logic, scrolling UI in your application with the player, for the smooth experience, you can try to implement something like player pool. And in the end, I think it is a good idea to think about analytics, because collecting key playback metrics will help you monitor engagement and troubleshooting performance issues. By following these principles, you can create a smooth and efficient video experience in your app. And in the end, let me share a few links for you. You can find here some link to about ABR algorithms and about DRM feature, because today we didn't touch it. And a few links about me. If you want to watch closer on this demo code, you can find my demo repository on the GitHub and use it. And that's it. Thank you all. If you have any questions, feel free to ask me.
Yeah, Andrei, thank you so much. This was a great presentation. Now we're switching to our Q&A session. We have just a few minutes to answer some questions from the chat. But in case your question wasn't answered, you can always contact Andrei in direct messages, and he will answer your questions in person. So we're community-oriented, and our main mission is to help you build incredible products. So this was a great presentation, very useful and very interesting for everyone who now integrates video feeds to their apps. And the first question is, how does Apple ecosystem affect the choice between MP4 and HLS?
I think we don't have any difference between that. In my experience, I saw and I had experiments with these formats. And I remember, if you work with a short format like a TikTok, it doesn't matter for you which format you want to use. Yeah, we didn't see any improvements for all of them. But if you work with the long content, I think HLS it is a better choice.
Yeah, great. Thank you so much. The next question, is autoplay a must-have for a modern video feed, or should users tap to play?
Yeah, I think it is an important moment, because now users don't want to spend a few seconds to tap on the screen. And yeah, it's a good practice to start your video playback immediately.
Yeah, the consumers have become very demanding for interfaces. That's 100% true. And the next question is, what's the best way to track whether user actually watch a video or just scroll past it?
For that, you can use a heartbeat event, what I mentioned before. You can adjust this event how you want. For example, in my experience, how we work with it, we just created some like a checkpoints. For example, 30 seconds, so next it is 6 seconds, and you can just track that user just watch to this position, and after that you can track event. User watched for this 3 seconds, and we can track it, and it allows us to understand that user not just scroll and skip our video content.
Great, thank you so much. Next question is actually very urgent, and I had the same question from myself. How do we make sure our video content doesn't slow down the rest of the app?
Our main metrics, it is feedback from our users. But I think when you work with a video, it's the same when you work with just regular UI. In my experience, maybe I had only one hard care with this situation, when we were integrating the hard SDK with building with the user interface, and we had some conflicts with video playing and rebuilding your UI. And if you just optimize your UI, I think it should work fine with your video player. And my main recommendation, just think about your base optimization in your application, in your UI.
Okay, Okay, great. Thank you so much. The next question is about AI. Will AI change how video feeds are built in the next few years, in your opinion?
I think AI, it is maybe really useful stuff for video creation, but for video playback, maybe in the future we can just see how we can render our frames faster, and maybe we'll use less powerful for that, less energy from our devices. But I think it is more important for the video content creation.
Yeah, great. Thank you so much. The next question is actually about performance again. Should we prioritize video quality or fast loading times for the best user experience? So video quality or loading time?
Mhm. Um, I think it is a quality. I think just depends on loading time, and HLS it is a good tool uh, for this resolving, because HLS allows you to start uh, just HLS download the first chunks, and you can download your first chunks in the minimal quality, for example, and after that you can just check if you have more resources. You can download more and highly quality with your video, and after that you can just adjust this moment and support both questions, but you have to think what is more important for you.
Okay, great. And here's also one more question from the same person, from Majo. If we add video, do we need a bigger backend infrastructure, or we just can use cloud services?
I think if you want to create a really good experience, and I think, yeah, for big company it is a good idea to create some special services, because as I mentioned before, if you work with HLS format, you have to transcode it, your videos, and yeah, for that you have to use a good programmers. But if you want to use your applications with just small features with the video content, maybe yeah, you can use a cloud for that.
Yeah, thank you so much. And the last question for today is, what's your personal favorite app that handles video really well?
uh, for me, maybe it is a Netflix, because Netflix has a lot of interesting features, and I can see how, yeah, it's doesn't affect the video quality and user experience.
Yeah, great. Thank you so much. Andrei, thank you so much for a session. And Andrei showed us a few links during the session. You can always find it below the video after we end our session. And in case you want to hear more about iOS development or video feeds or something else about mobile development, please contact us via our email on the website, or just reply to our newsletter that I hope you're already following, or just drop us a line in LinkedIn or somewhere, and we'll be happy to try to find a great speaker for this, or ask Andrei to make one more session on iOS development. So thank you for your support, and I hope to see you in our next webinars, community talks. Thank you, Andrei. Thank you, everyone. Bye
Thank you,
bye.
Grace.
Thank you. Bye.